Dependence and dependence of vectors is our topic today. Now, in my earlier lecture, I had already told you that if wait a minute, A is a row vector like this 2, 3, 4, and 5. This was a row vector, row matrix rather, I should say, 1 cross 4. There is one row and 4 columns. This was called a row matrix. Row matrix. Now it will be called as row vector. Row vector. These are just the coordinates in x, y, z, w. That are the coordinates. Let us say CB. If I write it in this manner, 3, 4, 5, 6, then this was a column matrix. Column matrix, as I told you in my earlier lecture. Column matrix. This is 1, 2, 3, 4, 4 rows and 1 column. So now it will be called as column vector. I hope these 2 points are clear. Now the point is I have to see whether they are now we have to check the linear independence and linear dependence. Now instead of writing A and B for these type of, now I will not use the word row matrix and column matrix. I'll use the word row vector and I'll use the word column vector. Now instead of writing A and B like this, I'll use the symbol alpha 1 here. Let us call it alpha 2 something. Instead of let us call it beta 1, something like that. So the definition of linear independence comes, and in linear dependence comes from this very concept is that if you have vectors, suppose we have vectors alpha 1 up alpha 2 alpha 3 up to alpha n vectors, and we have scalars x1 x2 x3 and xn such that such that x1 alpha 1 x2 alpha 2 x3 alpha 3 and so on and so forth, xn alpha n is equal to 0 should give me x1 equal to x2 equal to x3 and so on and so forth up to xn all zeros. Then alpha 1 alpha 2 up to alpha n are linearly independent vectors. Independent vectors. These are linearly independent vectors. So this is the definition of linearly independent. Now this is the definition. Now what would be the definition of linear dependence? We have vectors alpha 1 alpha 2 up to alpha n, and scalars are basically numbers x1 x2 up to so on and so forth xn, such that x1 alpha 1 and plus x2 alpha 2 up to so and so forth plus xn alpha n equal to 0, at least one x1 of the x at least one of x1 x2 up to xn is non-zero. That means, I mean to say, suppose x1 is non-zero, the rest are all zeros. Then also we can say this isn't linearly independent, then it is called linear dependence. At least one, I said. It may happen that x1 is not 0, x2 is not 0, and the rest are all zeros. Let me say x3, x4, and so and so forth, till xn are zeros. Or all of them are not zero. All of them non-zero. All of them non-zero. Xn non-zero. In short, if I say so, in short, if I say so, at least one of, at least, wait a minute, at least one of xi, I equal to, let me write it, I equal to 0 to, oh, sorry, 1 to n, 1 to n, sorry, 1 to n, 1 to n is not 0, then alpha vectors alpha 1, alpha 2 up to alpha n are are linearly dependent. That is, in short, we'll call it LD. And here on on this part, on on this part, we will call it LI. LI, linearly independent. And here we will call it L, LD. LD, linearly dependent. Now we will do certain examples and then we'll make the thing very clear. Now see, first example, question. Suppose I am given with one vector, say alpha 1. Alpha 1 is given as 2, 2, 1 transpose. These are all commas. Alpha 2 is given as 1, 3, 1 transpose. Alpha 2. And alpha 3 is given as 1, 2, 2 transpose. Wait a minute, let me write it clearly. Here it is 1, 2, 2 transpose. I know what you mean by transpose. See, now the formula is x1 alpha 1, x2 alpha 2, x3 alpha 3. It should be 0. So let's write down the transpose it is. So x1 2, 2, 1 plus x2 1, 3, 3 plus x3 1, 2, 2, because we are writing in transpose format. So 0. This will give me 3 equations. This will give me, now this is going to give me 2x1 plus x2 plus x3 equal to 0. 2x1 plus 3x2 plus 2x3 equal to 0. x1 plus x2 plus 2x3 is equal to 0. Now see one thing, this is in the format of ax equal to b, 0. Now there is no b. See, earlier we did ax, this is ax, earlier we did ax is equal to b, which is a non-homogeneous system, non-homogeneous system of linear equations we did in the earlier video. Linear equations. Now this is a system of homogeneous linear equation. This is homogeneous system of equations. So let me underline this word. Now for this, we saw in my last video, I made it very clear. If this is n equal to n, then you have no solution, unique solution, and infinite solution. In this case, we have only two cases. That is either in infinite solution or a unique solution which will be called a trivial solution. Let me discuss this first. Let me discuss this first. Ax equal to 0. Now see one thing. Suppose A is your, we will consider only the cases where this n cross n matrix type is there. We will only discuss this case because this is only in your syllabus. We will not go for a m cross n. Later on, if I get time, I'll take that n cross m also case. Now see, only two things will come here. See, if rank of A is equal to n, then only trivial solution, that is only unique solution, and the solution is x1 equal to x2 up to so on and so forth. Xn is always 0. Only the zero solution. That's why I have written trivial solution. Since it is a zero solution, I have written trivial solution. There is no other solution. Now suppose if the rank of this matrix A is less than n, then infinite solution. Wait a minute. Infinite solution, that is one of the solution is, that is one of the solution is this zero solution, but here it is only the zero solution, right? Now this is this case. Now we will do one thing. We will solve this equation, 2x1 this equation we will solve with this idea, with the idea just now I gave you. Wait a minute. This idea that I gave you, this idea and this idea. Let me underline unique solution and let me underline infinite solution. Now let me write this as in this. Now that equation, I'm talking about this equation. I'm talking about this equation, right? Let me copy it here for you. Let's paste here. Okay, I got the equation here now. Now I have this equation. Wait, let me draw the line for you so that, yes, this is the line. This is the line for you. Now you see, this can be written as 2, 2, 1, 1, 3, 1, and 1, 2, 2. Then you have x1, x2, and x3. Then you have all 0, 0, 0, 0. Now do one thing, interchange these two rows. R1 is to be interchanged with R3 is to be interchanged with R1. So what I get is now 1, 1, 2, 2, 3, 2, and 2, 1, 1. Now I will write it at x1, x2, x3, and this will be 0, 0, 0. Now the thing is this. Now I'll use the row operation. R2 is R2 minus 2R1 and R3 is R3 minus 2R1. Now the thing is that I'll get, wait, let me take some more space. Wait, yes, oh wait, yes. So now you have 1, 1, 2. You have 1, 1, 2. Wait a minute, yes. Then 2 minus 2 is 0. 3 minus 2 is 1. 2 minus 4 is minus 2. Now you have 2 minus 2 is 0. 1 minus 2 is minus 1. And 1 minus 4 is minus 3. And then you have x1, x2, x3. These are all zeros, and 0 subtracted with 0 will give me 0 only. Now I'll try to make this 0. So what I do is that I write the equation R3 is R3 plus R2. So what I get is 1, 1, 2, 0, 1, minus 2, 0, 0, minus 1, and I get x1, x2, x3, which is nothing but 0, 0, 0. Now see, there is a pivot in every row. This is one pivot, this is one pivot, this is also one pivot. You can do is that before you go for the pivot, wait, let me tell you one more thing. Let me rub this. Yes, do one thing. Go for R3 is minus R3. So what will happen is that you will have this 1, 1, 2, 0, 1, minus 2, 0, 0, 1, and then you have your x1, x2, x3, and then you have your 0, 0, 0. And now you have a pivot here, you have a pivot here, you have a pivot here. The number of non-zero rows. The non-zero rows, this is a 3 cross 3 matrix. Now the number of non-zero rows, rank of A is 3, which is equal to the number of variables. So the only solution is the trivial solution or a unique solution. So you have, so only unique solution, and you have only the trivial solution x1, x2, x3, 0. So the trivial solution only. Therefore, you only have this, since you have only have this trivial solution. So alpha 1, alpha 2 vector and alpha 3 vector are linearly independent because of this reason. Now we will take a case. Now see one thing I like, before I take another case, in some books they may do this. See what they may do. I'll show you. They may do this. Wait. Instead of writing alpha 1, they may write x1 here, x2 here, x3 here. Then you take the scalars as alpha 1, alpha 2, and alpha 3. Just to interchange. Here I have taken alphas as the vector and x's as the scalar. In some books they may do this, that they may take the x as the vector and alpha as the scalar. It is immaterial. So you must tell what are your vectors and what are your scalars. If you denote using alphas, the vectors, you write alphas are the vectors and x's are the scalars. In some books, they may say x's are the vectors and alphas are the scalars. The equation remains same. Now, instead of having x1 here, instead of having x2 here, and instead of having x3 here, you will have alpha 1, alpha 2, and alpha 3. And in this equation, wait a minute. In this equation, that is this equation, or you can call about this equation. In this, you will have now 2 alpha 1, alpha 2, and alpha 3. You will have 2 alpha 1, alpha 2, and alpha 3, alpha 1, alpha 2, and alpha 3. And here, instead of x1, you will have alpha 1, alpha 2, alpha 3. That is the change. Only the name changes. And the rest is here. Instead of writing this x1, x2, x3 as 0, you will write there as alpha 1, alpha 2, alpha 3, 0. And instead of writing alpha 1, alpha 2, these vectors, you will say x1, x2, x3 are linearly independent. That's the only change, nothing else. That's only the change of symbols, nothing else. Now let's take another example. Let us take a question. Let us take a question. Now I have, suppose x1, I'll tell you a shortcut so that you can do it directly in the examination hall. 1, 2, 4. Now you have, see, now I have used this as a vector. No problem. Now x2, I have writing it as 2, minus 1, 3. Now this is another vector. Now see, in the earlier cases, I wrote this as alpha 1 and alpha 2. Now I'm writing it x1 and x2 just for sake of change, so that you don't get confused if you see this way of writing. This is 0, 1, 2, and then you have x4 as minus 3, 7, 2. Now do one thing. You write this equation, alpha i's are scalars. Here, there, in the previous question, xi's were scalar. Now in this question, alpha i's are scalars and xi's are vectors. You must write that. And then do one thing, shortest way of writing is, look, how many vectors you have got? 1, 2, 3, 4. Just write them in columns. This is in row, na? Write it in column. 1, 2, 4. Then you write 2, minus 1, 3. Then you write 0, 1, 2. Then you write minus 3, 7, 2. And then you write your scalars as alpha 1, alpha 2, alpha 3, and alpha 4. No problem. And this comes out to be 0, 0, 0, 0 because this is a 3 cross 4 matrix. This is a 3 cross 4 matrix. Just I made one more 0 unnecessarily. Wait a minute. This is a, wait. Oh, sorry. This I need. This. Let me rewrite it. This is a 3 cross 4 matrix. This is a 4 cross 1 matrix. The result will be 3 cross 1 matrix. 3 cross 1 matrix. Keep this thing always correct. Otherwise, we will land into trouble. Now I will do is that I'll take the row operations. I'll take the row operations, only row operations. Now no more column operations will use. Or you will use column operation in the normal form that I showed you earlier. R2 is R2 minus 2R1. Then you have R3 is R3 minus 4R1. Now this is the story for you. Now do one thing. Now this is 1, 2, 0, minus 3. Then this is 2 minus 2. This is 0. Minus 1 minus 4 is minus 5. Then you have 1 minus 0 is 1. 7 plus 6 now it will become, that is 13. Now you have 4 minus 4 is 0. 3 minus 8 is minus 5. And then you have 2 minus 0 is 2. Then 2 plus 12, that is 14. Here you will have alpha 1, alpha 2, alpha 3, alpha 4, and then you will have 0, 0, 0. Now, the next operation, let me give this here. Yes. Yes. Now, you have R3 is R3 minus R2. You have to make this 0. So, let me rub it. Now, you have 1, 2, 0, minus 3, 0, minus 5, 1, 13, and then 0, minus 0, minus 5 plus 5, 0, 2 minus 1 is 1, 14 minus 13 is 1. Now you have alpha 1, alpha 2, and alpha 3, and alpha 4, and you have 0, 0, 0. This you have got. Now, the thing is this, you can see, now you can see one thing, that the rank of this matrix is not 4 but 3. The rank of this matrix is not 4. So, see, here you can always see the rank of this matrix is not 4 but 3. So, what you do is that you try to do one more thing. You try to make this 0. Make this 0. See how. You will do one thing. You can do R2 is R2 minus R1, R3. So what you will get is 1, 2, 0, minus 3, 0, minus 5, sorry, 0, 0, 1, 1, and then minus 5, 0 is minus 5, 1 minus 1 is 0, 13 minus 1 is 12. Now this is the way you did it. Now, see one thing, very simple. Do it this way, alpha 1, alpha 2, alpha 3, and alpha 4. This comes out to be 0, 0, 0. Now you will see one thing. See, now the rank of this matrix is 3, which is less than 4, the number of variables, so so infinite solutions, infinite solution, right? Now, this is one thing you have seen. Now supposing infinite solutions, hence I think I wrote x1 vector, x2 vector, x3 vector, and x4 vector are linearly dependent, number one point. Now, further I can do one thing is that I can try to write down how. So that means, see, this one corresponds to, let me mark with some other color. This one corresponds to x1 vector. This one corresponds to x2 vector. This one corresponds to x3 vector. And this one corresponds to x4 vector. Be very careful. This was your x1, this was your x2 vector, this was your x3 vector, and this was your x4 vector. Now reduce it into a reduce this matrix further. So see how will I do it? Wait, I will just a minute, let me set the page for you. Yes, what I'll now do is that now this is 100, no problem. I'll try to make this 100. This is also 001, forget it. I'll try to make this 100 only using row operations. So see what I'll do. I'll write, wait a minute, I'll write R2 is equal to minus, I'll replace R2 by minus 1 by 5 R2. So now you see what happens. Now you see what happens is this. Let me copy this matrix below. I think that would be easier. I think that would be easier. If I copy this matrix here, wait, let me copy this matrix. Let me copy this matrix. I have to copy this matrix. Wait, yes. Copy. Let me copy this down. Let me copy this down here. Wait a minute. Wait a minute. Let me copy that matrix. That would be easier. Wait a minute. Let me copy this matrix. Let me copy this whole matrix. See, let me copy this matrix. Let me copy it here. Wait. I'll copy it somewhere. Let me rub this and let me copy this here. Then I'll make you understand a very, very nice concept. Let me copy it here. Paste. Yes, here it is. Here it is for me. Now do one thing. This was the matrix for me. This was the matrix for me. Now the idea is, see the idea what to do. I'll make reduce this matrix completely to an identity matrix. What I'll try to do is that, oh wait a minute, I'll try to make this one. Try to make this 0. That's the point. Only these 2 points I have to do. Now see what happens. That matrix I've copied here. This corresponds to x1, this corresponds to x2, this corresponds to x3, this corresponds to x4 vectors. Now see the point here. Now I will do one operation. The operation would be R2 is to be replaced with minus 1 by 5 R2. So what I'll get is that I'll get 1, 2, 0, minus 3. I'll get 0, 1, 0, minus 12 by 5. And then I'll get 0, 0, 1, 1. No problem. Now what I will do, I'll try to make this 0. Now that what I do is that R2, R1 is R1 minus 2 R2. So now I will get is 0, 1, 0, minus 12 by 5 while writing those rows. 0, 0, 1, 1. And then 1 minus 1 is 1. 1 minus 0. 1 minus 0 is 1. 2 minus 2 is 0. 0 minus 0 is 0. Now see, this is minus 3 plus 12 by 5. Because the 24 by 5, sorry. 24 by 5. Sorry. This is 24 by 5 because this row is getting multiplied with minus 2 here. So this is becoming to be plus 24. So this is minus 15 plus 24 by 5, and this is nothing but 9 by 5. So let it be 9 by 5. Now see a very, very interesting case. Very, very interesting case. You can see now. Once you have done this, you converted this into a identity matrix. This corresponds to the x1 vector, x2 vector, and x3 vector. Now see, this corresponds to the x4 vector. What was the x4 vector? Let's write it down. Let's write it down. Let's write it down. See, x4 vector was minus 3, 7 by 2, right? This can be written as, see, this 9 by 5 will come here, and this corresponds to the first vector. What was the first vector? 1, 2, 4. Next, then you have minus 12 by 5. Minus, I think not 12 by 5, it's 9 by 5. Sorry, I made a mistake here. It's plus, no, minus 12 by 5. I'm correct, I'm sorry. That was 9 by 5. 12 by 5, sorry. 12 by 5 minus 12 by 5. Then you have your which vector? It is your 2 minus 1, 3. And the last one is plus 1 here. Here it is. Let me write it clearly. Wait a minute. Let me write it clearly. And this was plus 1. Here this plus 1 with this vector, that is 0, 1, and you have 2. Now let's check. 9 minus 24. What is 9 minus 24? 9 minus 24 is minus 15. See, what I'm doing is this. See, now I will get this. I'll calculate this and I'll get this vector. See, see, see. 9 by 5 minus 24 by 5. I'm doing the x coordinate, this coordinate, this coordinate, and this coordinate plus 0. Now write it like this. 9 2s are 18 by 5 plus 12 by 5. Now you have 9 4s are 36 plus 1. Sorry, just a minute. I forgot this last one. Plus 1. Wait a minute. Plus 1. Now you see, this is basically 9 4s are 36. 36 by 5. Then you have minus 36 by 5 and plus 2. Can you see? You are getting this only. This is, you add up, this is how much? This comes out to be 15 minus 15 by 5. 15 by 5. And this comes out to be, let's say, this is 6 by 5. This is, no, not 6. This is 18 to 20 and 30. 6 plus 1. And this comes out, it cancels out. This is 2. And you get is minus 3, 7, and 2. Did you see? You got this vector by the linear combination of these vectors. See, alpha 1 is not, x1 is not 0, alpha 1 is not 0, alpha 2 is not 0, alpha 3 is not 0. Therefore, this vector has been expressed in terms of these vectors. These vectors. So this is linearly dependent. Now, supposing you want to find this infinite solution. Now you talk about how this infinite solution is this. So what you do is that you take this equation. You take this equation again. You take this equation again. This equation is, let me write down the final part of the equation. This is 1, 2, 0, minus 3, 0, minus 5, 1, 13, and you have 0, 0, 1, 1, and you have alpha 1, alpha 2, alpha 3, and alpha 4 is equal to 0, 0, 0. You write down this way. Alpha 1 plus 2, alpha 2, minus 3, alpha 4 equal to 0, minus 5, alpha 2, plus alpha 3, plus 13, alpha 4 equal to 0, and then alpha 3 plus alpha 4 is 0. Take alpha 4 as k. You take alpha 4 as k, then you have alpha 3 is minus k. Put the value of this and this in this equation. Minus 5 alpha 2 is minus k plus 13k. You get this as 0. So alpha 2 comes out to be, this comes out to be something like 12k by 5. Now put the value of this and this in the first equation to find alpha 1. Now you can find alpha 1. Wait, what is your alpha 1? Your alpha 1 is plus 2 alpha 2. 2 alpha 2 is 2 times 12k by 5. And then you have your minus 3 alpha 4. Your alpha 4 is k. Alpha 4 is k, and the whole thing is 0. Alpha 1 is now equal to 3k minus 24k by 5. Now you take the LCM, this becomes minus 15k plus 24k by 5, which comes out to be minus 9 by 5k. Now see one thing. See one thing very clearly. See one thing very clearly. See, here you must have observe one thing very clearly. This is your value of alpha 1. This is your value of alpha 2. Well, let me write with some different color. Wait, otherwise you will get confused. Let me write it with some color here. This is your alpha 1. This one is your alpha 2. And this one is your alpha 3. See, alpha 3 is this, right? That means in the previous part you got alpha 1, and here alpha 1 is for how much? Minus 9 by 5. That means, and here alpha 1 is 9 by 5, and here alpha 1 is minus 9 by 5. That means alpha 4 has to be minus 1. If alpha 4 is minus 1, right? Alpha 4 is minus 1, then only alpha 1 will be 9 by 5, right? Then alpha 2 will be minus 12 by 5, and you can see alpha 2 is 12 by 5. Alpha 2, let me use this color. Alpha 2, this is alpha 1, more bright it is, and this is your alpha 3. Now you see, I had written alpha 1, alpha 2, and alpha 3 in this way. I found out, and I'm trying to find out in this manner now. Now this alpha 1 is coming out to be this. So alpha 4 must be minus 1. Otherwise, alpha 1 cannot be plus 9 by 5. So this is now 9 by 5. Wait a minute. Wait a minute. Yes, let me rub and write it clearly. Let me rub it. See, alpha 1 there in that method, in the method I made you see here, this method that I made you see here, this method that I made you see here, I got alpha 1 as 9 by 5, I got alpha 2 as minus 12 by 5, and alpha 3 as 1. Now see. So alpha 1 in that method I got, let me take this. Alpha 1 was minus 9 by plus 9 by 5. Alpha 2 I got as minus 12 by 5. I hope I remember. And alpha 3 as plus 1. Right. Here what I got is, see, I got alpha 1 as minus 9 by 5k. I'm comparing, see. Alpha 2 I got as 12k by 5, and alpha 3 I got as minus k, and here I got alpha 4 as k. Here in this method I'm talking about, in this method. Now if I take alpha 4 equal to k equal to minus 1, you will get this value. See, you will get alpha 1 as, what will you get alpha 1? What will you get alpha 1? See, what will you get alpha 1? Alpha 1 you will get as, you put minus 1 here, so you will get 9 by 5. You put minus 1, here, you will get alpha 2 as minus 12 by 5. You put alpha 3 as minus k, minus and minus will give you plus. So you saw this method, both these method gave you linear dependence. So see one thing, what actually I did, it was there, understand the situation. See, since the rank was not the same, it had infinite solutions. So that means the last vector, this corresponds to x4, I told you. This corresponds to x2. This corresponds, x3, and this corresponds to x2, and this corresponds to x1. That means I have written x4 in terms of x1, x2 and x3. That means this vector is dependent on these x1, x2 and x3. I did this calculation. You may not show this calculation in the examination hall. I did this calculation to make you understand that the result gives me the same value. Wait, the result gives me the same value. The result gives me the same value. I hope you have understood this topic here. One more trick I'll tell you. See, one thing. If for an n cross, this was not an n cross n matrix. This was basically what type of a matrix it was. It was a 3 cross 4 matrix. This was a 3 cross 4 matrix. Now the previous example, in the previous example, I had in this example, I had a 3 cross 3 matrix. I had a 3 cross 3 matrix, right? I had a 3 cross 3 matrix. Now I will show you. See, you already had this matrix, this matrix, this matrix. You had this matrix. Let me copy this matrix. Wait a minute. Let me copy this matrix. I'll show you one more method. One more method I will show you. I'll show you one more method. Wait. You see this. You copy this matrix. Let me copy. Let me bring it here. I'll show you one more thing. Provide I can do only this method if I have an n cross n matrix. Otherwise, I can't do. Now see what I'm doing. I am pasting that matrix here. Yes, here. So what I'll do is that I will, oh sorry, this is a matrix, that matrix. I'll take the determinant of this matrix. This was that matrix A, let us say. I'll take just the determinant. And you know you can, by row and column operations, you can reduce this matrix by this to this one. You can reduce this matrix to this one. What was it? What was it? The last option? Yes. Here it is. See, I reduced it to 0, 1, 2, 0, 1, minus 2 and 0, 0, minus 1. 0, 0, minus 1. See, I'm finding the determinant. I can use this determinant method also. You can understand here. See, I got this as C. I got this as 0, 0, 0, sorry, this is 1. I got this as 1, 1, 2, 0, 1, minus 2, and then I made it into 0, 0, 1. I'm sorry, I'm taking the determinant. Taking the determinant. Wait, let me take the determinant. The determinant comes out to be plus, minus, plus, and if I take the determinant by hiding this row and hiding this column, I get is 1, which is not 0. That, and this is only possible if it is a 3 cross 3 or 4 cross 4 or 5 cross 5. I cannot do it for this the previous one which I did, that is 3 cross 4 matrix. Now since the determinant is non-zero, determinant non-zero, so rank of A is here 3. So all the vectors, so all the solutions, what did I take there as? I think I took them as x1 equal to x2 equal to x3 equal to 0. So linearly independent. I can use the determinant method. If the determinant is non-zero, then it is always linearly independent. That means determinant non-zero, vectors are linearly independent. You can write provided A is n cross n matrix. You get an n cross n matrix provided you get this. I hope you understood this chapter. Now we have got two questions. Question number 1 and question number 2, in which we have to check whether they are linearly independent or linearly dependent. And if they are linearly dependent, then how can one vector be expressed in terms of the other vector? These are the two important points that we need to understand again. Continuing with that topic of linear independence and linearly dependent. So let's do the solution. Now let's do the solution. Let us take the first question, method 1. Question 1. Let us see method 1. Method 1. Method 1. Now you can write this always, whatever vectors are given to you, you always write it in column form. Column form, I mean to say, you write this vector in this manner: 1 1 1 1 2 3 and 2 minus 1 1. Now See, if this vectors, this 1 1 1 and 1 2 3 as they are written, instead of this, had it been written in this manner, let us say in this manner, let us say in this manner, 1 1 1, then you would have copied, and then 1 2 3, and then your 1 2 1 minus 1, then you could have copied as in this manner only. But since they have been written in row wise, you have to write it in column wise. The first thing is this. Now take the determinant. Take the determinant. Why you can take the determinant? Because it is a 3 cross 3 matrix. Now take the determinant. 1 1 2 1 2 minus 1 1 3 1. Now use row operations. R2 is R2 minus R1, or you can just expand the determinant the way you feel like. I'm doing it this way. R2 minus R1, and R3 is R3 minus R1. Now what you get is this from here. After these operations, a determinant becomes something like that. 1 1 2. 1 minus 1 is 0. 2 minus 1 is 1. Minus 1 minus 2 is minus 3. 1 minus 1 is again 0. 3 minus 1 is 2. And 1 minus 2 is minus 1. Now you can do one more thing. Make this 0. Use a, sorry, this line has been drawn in wrong manner. This has to be a straight line. Now you have to make this 0. So what you do is that take R3 is equal to uh, R3 minus 2R2. Now what you get is that, now let me scroll down a little bit. Now what you get is that this determinant now takes the form 1 1 2, 0 1 minus 3, 0 minus 0 is 0, 2 minus 2 is 0, minus 1 plus 6, that is 5. Minus 1 plus 6, that is 5. Now you take the determinant. Just you take the determinant. You take the determinant. So expand in this manner, plus minus plus. So you expand in this and in this manner, in the last row and the last column, third row and the third column, I mean to say. So you have 5, and then you have 1 minus 0, and the answer is 5. This is not equal to 0. So the vectors are linearly independent. This is this thing. Or you can do is one more thing. Or the method 2 is method 2 is method 2. Method 2. You can do one thing is that you write down those this as x1 alpha 1, x2 alpha 2, x3 alpha 3 equal to 0. Now what are these alphas? Alphas are those vectors. So what you do is that you write straight away the matrix in this manner. See, you write the matrix straight away in this manner. That is 1 1 1. You have 1 2 2 3, and then you have 2 minus 1 1. You write x1 x2 x3, and then you have your this 0 0 0. Now you take the row operations, the same row operations. That's why I've taken the row operations up. The same row operations, if you take these operations I'm talking about, these operations, if you take these operations. So let me copy these operations here. Let me copy these operations here. Here I'm copying these operations. You can now do it. You have learned all this now. You just have to paste these operations. Wait a minute. Let me put it somewhere here. Here, yes. Now, just a minute. Yes. Now, with these operations, what you get is the matrix like this. You got which matrix? Just a minute. Let me copy paste that matrix only. That would be an easier way out. So I got this final matrix. This matrix. I'll just copy this matrix. That's all. Wait a minute. Let me copy this matrix. Just this matrix. That would do the job. I'll just copy this numbers, digits from here, and I will paste it somewhere here. See, I paste it here. I get this. I move it a little bit here. And now what I do is that, because I'll get the same thing, there will be no change. Just let me rub this line, rub this size symbols, put the minus 1 here as it was, and like this. Now you have x1, x2, x3, and you have, sorry. You have this 0, 0, 0. Now you can see the rank of this matrix is 3, which is equal to the number of variables number of variables. So therefore, x1 equal to x2 equal to x3 is 0. So this is linearly independent, and this is a trivial solution. This is a trivial solution. So in case of linearly independent, you will get a trivial solution. When you get a trivial solution, it is linearly independent, undoubtedly here. Now this does the job for you. Now I will take the second question for you. We will take the second question. Let us see. We will take the second question. The second question we will take. Wait. Yes, here we are with the second question. That is this one. We will take this question now. We have got 1, 2, 3, 1, 3, 5, 1, 0, 1, 2, 3, 0. And we have to see whether they are linearly independent or not. The way I explained you here, you write everything in a column manner. But now you will see this will become a 3 cross 4 matrix. So determinant method won't work out here. So you have to go by this method too. You have to go by this method too. The determinant method, the determinant method won't work because this is not a 3 cross 3. This will not form a 3 cross 3 matrix. Let us do it now. Question number 2. Question number 2. Question number 2. We will write this same as like this. Let us write this vectors x1, alpha 1. What is alpha 1? Alpha 1 is 1, 2, 3 with some commas plus x2. What is my next vector? 1, 3, 5. Now what is the next vector? X3, and that is 1, 0, 1. And this is my last vector x4, and this is 2, 3, 0, 2, 3, 0 with commas, and this is 0, 0, 0. Basically this is actually like this only. We used to write 0. Now that means I'm talking about a 0 row vector. Actually this and this are the same thing. Now I told you the shortcut. You write 1, 2, 3 like this. You write 1, 3, 5 like this. You write 1, 0, 1, and then you have 2, 3, 0. And this is now a 3 cross 4 matrix. Your determinant method won't work. You have x1, x2, x3, and x4, and you have your, this is a 3 cross 4, 4 cross 1. So you will get 0, 0, 0. You will get a 3 cross 1, undoubtedly. Now you make this row, this one 0, this 0. How? R2 is R2 minus 2R1, and you have R3 is R3 minus 3R1. Now what you get is, let me scroll down a little bit. Yes, I can take this much. Yes. Now you see what you will get is 1, 1, 1, 2. Then you will have 2 minus 2 is 0. 3 minus 2 is 1. 0 minus 2 is minus 2. 3 minus 4 is minus 1. Now in this 3 minus 3 is 0. 5 minus 3 is 2. 1 minus 3 is minus 2. And 0 minus 6 is minus 6. So now you will have x1, x2, x3, x4, and now you will have 0, 0, 0. This is the thing now. Now the target is, now do one thing. You divide this the third row by 2. So R3 is half R3. This will help me out in calculations. That's why I'm doing this. So what you will get is 1, 1, 1, 2, 0, 1, minus 2, minus 1. Then you will have 0, 1, minus 1, minus 3. And then you will have x1, x2, x3, x4. Now you will have 0, 0, 0. You can keep it like this. This is, now the idea is to make this 0. Make this 0. Now let us do it. How did we? R3 is R3 minus R2. So now this is going to be 1, 1, 1, 2, 0, 1, minus 2, minus 1. Now you see 0 minus 0 is 0, 1 minus 1 is 1, minus 1 plus 2 is plus 1, minus 3 plus 1 is minus 2. This will be 0, sorry. Now you see Now there is a pivot in each what you can call each row. So now you can see this is 0, 0, 0. Now the rank of this matrix is 3, which is less than 4. The number of variables. So the vectors are wait a minute, are linearly dependent, LD. Now the question, if you see the question, they are asking, if you see the question, you see here, wait a minute, you see here, just a minute, just a minute. Yes, you have this question here. Here it is the question that if they are linearly dependent, that means I'm talking about is this. If they are linearly dependent, then how can one vector be expressed in terms of the other vector? This is the second part. Now we have found they are linearly dependent. So now we will carry on further. Now what I'll do is that I will just copy this matrix. I will just copy this matrix again. See what I'm doing. I'm copying that matrix here. Now you see, you will only use row operations. So what I'm doing is that on this matrix, I'm applying this row operation, that is R2 minus R2 plus 2 R3. So what is happening is that I'm replacing the row. See, R2 plus 2R3. See, I'm adding these two rows, these two, these two, these two. So 0 plus 0 is 0, 1 plus 0 is 1, minus 2 plus 2 is 0, minus 1 plus minus 4 is minus 5, and then the remaining all are same here. Now on this matrix, I am using this operation. Now on this matrix, when I use this operation, wait a minute, yes, when I use this operation, R1 is R1 minus R3. I write the second row as it is, and I do one thing. I write the third row as it is, and then what I do is that I subtract R1 minus R3. 1 minus 0 is 1. 1 minus 0 is again 1. Then here, see, 1 minus 0 is 1. Wait a minute. Just a minute. I made a wrong this. I'm getting this matrix from here. From here, I'm getting this matrix. So 1 minus 0 is 1. 1 minus 0 is again 1. 1 minus 1 is 0. 2 minus 2 is plus 4. This I got. Now what I do is that, wait, let me now rub these lines, these ticks, so that now I will be operating using this operation to get this matrix. I will using this operation on this matrix so that I get this matrix. Now you see how I do it. Just a minute. Yes, yes. See, this is the second row and the third row will be copied as it is because we are doing operation in R1 and R2. Now see, 1 minus 0 is again 1. 1 minus 1 is 0. 0 minus 0 is 0. 4 minus 5 is 4 plus 5, and that is 9. I hope you have understood this now. Now see one very important thing. Now the discussion is very, very important for you all. The thing is, and let me rub all this now. Yes. Let me take a different color. Now this has become basically, this thing has become basically an identity matrix. Fine. And this is something different. Now this first column corresponds to alpha 1. The second column corresponds to the alpha 2 vector, alpha 3 vector. Now this column basically tells me that how alpha 4 will be written in terms, sorry, just a minute, in terms of alpha 1, alpha 2, and alpha 3. Now see how what I do. I will just drag it a little bit more. I'll take some more page. Yes, wait, yes, now you see. This is It was 2, 3, 0. Now you have alpha 1 is this is 9. 9 times alpha 1. Alpha 1, this will be alpha 1 minus 5 times that will be alpha 2 minus 2 times that will be alpha 3. I think I remember alpha 3, 1, 0, 1. And let me see alpha 1 and let me see alpha 1 and alpha 2. Alpha 1 and alpha 2 are 1, 2, 3 and 1, 3, 5. 1, 2, 3 and 1, 3, 5. Wait a minute. Let me come down. Yes. 1, 3, 2 and 1, 3, 5. I hope so. I'm right. Let me check again. Otherwise, 1, 2, 3 and 1, 3, 5. 1, 2, 3, 1, 2, 3, 1, 2, 3. It is, sorry. 1, 2, 3. It is 1, 2, 3 and 1, 3, 5. Now these are all commas. These are all commas. Now you will see is that this expression is absolutely correct. I will show you how. I'll check it for you. See here. Here, what I'll do is that I'm doing the check. I'm doing the check. This you can do in your rough work. See, 9 into 1, the coordinate wise multiplication and addition. Minus 5, minus 2. Now you have 9 twos are 18, minus 15, minus 0, and then you have 9 threes are 27, minus 25, minus 2. You can see this comes out to be 9 minus 7 is 2, 9 minus 7, 18, that is 3, and this is 27 minus 27, and this comes out to be 2, 3, 0. Now you have seen how this 2, 3, 0 has been expressed in the terms of the alpha 1, alpha 2 and alpha 3. These are the scalars x1, x2, x3. This is the way you will express this vector in terms of this alpha 1, this alpha 2 and this alpha 3. This is the way you will express. I hope this check is not necessary. You can do it in your rough. You can do this check in your rough work. Whether these x1, x2, x3 are correct or not. That's it.